Today we are going to find the composition of functions. This is the second half of the lesson. Actually, the first half was lesson 1-2. This is going to be lesson 1-3. They just happen to be using the same notes. So lesson 1-3. So if you want to know what 18 and 19 were above, they're in the last video. Okay, so the key concept for today is composition of functions. So the previous lesson we added, subtracted, multiplied, and divided functions. In this lesson, we're going to find what's called the composition of functions. And this is what the notation looks like. It looks like GOF, but it's read G of f of x. So this open circle is just, it means the word of. You could also write it as, and I don't see that they've written it here, oh, down here. You could also write it as f of g, and then usually it has of x. You'll notice that sometimes they'll drop off the of x part here. And then this is also the alternate notation, and this is the notation I prefer because it really tells you what we're doing. What this means is we're going to take a function called g, and we're going to substitute into it an entire other function, in this case called f. And so if you recall from lesson 1-1, we talked about function notation. This right here is the input for g. So it's saying we're going to input into g, into any x that's in our g function, the entire f of x function. And so you'll see me using that. So we're going to go ahead and look at these two functions here. So we have the f function, which is x squared, and I'm going to put that in blue. And we have the g function, which is x plus 3, and I'm going to put that in red. So I like to use big parentheses, and we are starting with the g function. So you need to go from the left to the right. So whether you're going to use this notation or this notation, you're going to start with the g function, start with the g function. So here's my g function. Wherever there's an x, I'm going to put big, huge parentheses instead of the x because we're going to use substitution. So this blank spot is where you need to put your great big parentheses and then plus 3. So wouldn't you agree that this right here is g of x, x plus 3. Then we are going to input into g of x the f function right here. And so that's what they're saying is g, and the input is f of x. I like to write it so it would look like g of f of x. Okay, so we're going to take that f of x and we're going to put it here. Okay, so again, all I did was take the g function, so ignore the x squared, this is the g function's x plus 3. Then we take the f function and we're going to substitute it right in here and create a whole new function called g of f of x. And this cannot be simplified any further, so your actual answer is x squared plus 3. That is the composition of g of f of x. Now we're going to reverse it. We are going to find f of g of x. And so they've started it here for you, but I'm going to write the notation that I prefer over here to the side, f of g of x. So really what we're going to do is we're going to take the f function and substitute into it, for every one of its x's, the entire g function. So our f function is x squared. So we are going to take, I don't even like that they did this already, so I'm going to do it below. So I usually will take, well, I'll do it over here. My f function is x squared, so big parentheses squared. This just represents my x squared. Then we're going to take and input the g function in for that x here. So remember, your g function is x plus 3. So that's going to go right in here. So let's do that. X plus 3. Now you have to be careful because, again, we talked about this before, when you are squaring a binomial, it is not x squared plus 9. It actually has a middle term. If you recall that x plus 3 squared is equal to x plus 3 times x plus 3. And then you need to FOIL or double distribute. So x times x is x squared. X times 3 is 3x. Then we're going to distribute the 3. 3 times x is 3x. I'm going to line it up with its like term. And 3 times 3 is 9. And then you will combine like terms. And so that's what they have done over here. So over here, let's fill in, you're missing the squared right there. And then what they've done is combine like terms. So the x squared came from bringing this down. And then 3x plus 3x is 6x. I'm going to bring this down. That's a 2. 6x and then plus 9. So that means that this is 6x over here and then plus 9. So this is actually your composition of f of g of x. So notice that g of f of x is x squared plus 2, and f of g of x is x squared plus 6x plus 9. So they are quite different from each other. All right, so let's look at problem 3. And there are two different methods for what we're going to do. I prefer one over the other. You can do whatever you like to do, but I'm going to show you the one that I like to do first. And I'm really not going to pay attention to what they're doing. I'm going to do it down here below. So let's ignore this for right now, and let's do our problems here. So we need to find f of g of x, because that's all we're going to do today. So we're going to do f of g of x. So f of g of x. And how do I know that? Look at the original problem above. They want you to find f of g. And this of -3, we're going to ignore it for right now. We're going to find f of g of x first. So we're going to find the composite function first, and then we'll plug in the -3. So this is going to be method 2 according to them. I'll call it way 1. So I like to call this way 1. So way 1, mostly because I like this way better. Okay, so we're going to start with the f function, which I'm going to put in blue, and the g function, which I'm going to put in red. So if I start with the f function, I have to have big parentheses where the x is, so big parentheses, and then -5. So again, all this is x minus 5, which is the f function. Then we're going to take the g function, which is x squared, and it gets substituted in for the x that was in the f function. So here we go. Substitute in the x squared, which is the g function. And we cannot simplify that any further. So f of g of x is simply x squared minus 5. That's part 1 of this. Then we have to plug in our -3. So now we're going to find f of g of -3. So essentially, I am going to evaluate this composite when x is -3. So I'm just going to put -3 in wherever you find an x. So I want to make sure I have substitution parentheses only around the x. So this equals parentheses squared minus 5. And I'm just going to put this -3 in wherever I have parentheses. So right there. So then -3 squared is positive 9 minus 5, which is positive 4. Okay, way 2. Way 2 is you just plug it in all at once. So way 2. Well, actually, you could find, okay, so let's talk about this. You could find, so for way 2, you could take this -3, and you could work backwards. So you could take the -3, plug it in the g function, and then get a value. When you get that value, you could plug it into the f function. So let's find g of, whoops, I want black, g of -3. So my g function is x squared. So x squared. Instead of the x, we're plugging in -3. -3 squared is 9. So then we're going to take, and actually I'm going to erase that 9 because I want to change the color and I want to make it red. So 9. Then you're going to take that value and you're going to plug it into the f function. So I'm going to take that 9 and it becomes my input for the f function. And so your f function is x minus 5. So parentheses minus 5. And that 9 becomes the input for that function, and 9 minus 5 is 4. So no matter how you go about it, you still get the same answer. Now I have lots of kids that when we're doing this right here, instead of putting the x squared in, they go ahead and put the -3 in right there. So they have parentheses, -3, that -3 should be in parentheses, to be honest, squared, and then minus the 5. Sometimes it gets a little confusing. You get some of your work wrong and you end up with the wrong answer. So it's not my favorite, but you could do it that way. Okay, problem 4. A store is offering a 15% discount on all items. Also, employees get a 20% employee discount. Write composite functions. So the first one is the model taking the 15% discount and then the 20% discount. So all of this is on the next page, and give me a minute because I'm going to write down the values because I'm not going to be able to see it. If you have your notes in front of you, you can see it. So we have the store offering a 15% and the employee gets a 20%. Okay, so I think we're going to go to the next page because I believe that's where they're prompting you. So here we go. All right, so let X be the price of the item. So we don't know the price of the item, so that's why we are letting X be the price of the item. You can name, all right, so I think my stuff, oh, no, there it goes. It was messing up on me, so here we go. So we're gonna let X be the price of the item, and we're going to write functions to model each discount. So the cost using just the store-wide discount would be 100% of the item. So here we have 100% of the item. And then we're going to discount it, so we're going to subtract it. If we were adding a charge to it, like maybe tax or a markup, then you would add here instead of subtract. But we're discounting, so that's why it's a negative. So if the store is giving a 15% discount, then we are going to write this as 0.15, and 1x minus 0.5x is going to end up giving you 0.85x. So you're really only paying 85% of the original price for that item. Then the cost using just the employee discount, so the employee discount is actually 20%. So we would subtract from X 0.2, and then 1 minus 0.2 is 0.8x. So clearly, you're better off getting an employee discount than a store discount. Now the question is, as an employee, when I go to buy an item, are they going to give me the store discount first, and then do I get my employee discount off of this 85%? Or are they going to give me my 20% discount first, and then I get a 15% discount off of that? So let's see. So this one, so next 27 says draw a line from each composition to its role. So we managed to find a function for both C and D. So basically, the first one here is saying you're going to take D and plug C into it. So D is this one right here. So that should come first, 0.80, parentheses, and then you're going to put this one into here. So the 0.80 should come first, and then the 0.85 in there. So this one goes to here. And then for this one, it says start with C. Well, C is 0.85, and then parentheses, instead of this X, we're going to put the 0.8 in. So this one's going to go to this one, And there we go. So then we're going to simplify each function. So we're going to actually multiply out. So for dc of x, and I'm going to put this around it here, this is actually going to equal 0.8 times 0.85. And we get 0.68 x. Then if you multiply this out, 0.85 times 8, don't you get the same thing? If you were an employee, which discount would you take and why? Well, it doesn't really matter. Well, let's just see, did this really work out correctly? So let's take $100, just for chuckle's sake. I have a $100 item, okay? Now, either the store took their discount first and then gave me my, my discount, right? So if the store discount is 15% off of $100, I'm paying 85% of that, right? So times 15%, well, it doesn't matter. 85%, wouldn't you agree that 85% would be $85? So this is with the store discount. This is store discount. Then I would want to take my 15% off of that. So times, well, if I multiply it by my 20% discount, 0.2, $85 times 0.2 is $17. So that's what I'm going to take off of the 85. So with my store discount, so final dollar amount is going to be 85 minus 17, which is $68. Didn't that match the 0.68 here? And so let's reverse it. So instead, I'm going to again take my $100 item, and then we're going to take our employee discount. So if I took my employee discount, which is 20%, we're going to be paying 80% of it, so we end up paying $80 for it. So that's with my employee discount, right? And then I'm going to multiply that times 15%, because then I get my store discount off of that. So 80 times 0.15 is $12. So you're like, well, it looks like you're getting less off, but I started out paying less for it in the first place. And what is 80 minus 12? Gee whiz, that final dollar amount is $68. So they are both the same. In this case, it doesn't matter. So my answer to this would be, it doesn't matter because both methods are equal. It really looks like I'm a kindergartner drawing on here. Sorry. All right. And so that's really the end of the lesson. The lesson check is for you to do on your own if you'd like, and if you need the answers, feel free to text me or email me with your work to see if you're correct. Have a great day.